So let us start. So rectilinear motion. Okay, so in the rectilinear motion, right? So we dealt with the normal scenarios. So that is with d square x by dt square may be a function of time, right? Now actually we are going to deal with if it is a constant, that is d square x by dt square equal to some constant a or f. Now here this is being constant. If you integrate on either sides, so dx by dt is equal to ft plus some arbitrary constant c. But dx by dt is called as the velocity v. Now from this actually v is equal to ft plus c. Now the initial conditions are at t equal to 0, let the initial velocity be u. So if the initial velocity is u, then u is equal to 0 into f plus c. It implies c equal to u. Now if you replace there, v is equal to u plus ft. So this is the relation between the velocity and time. That means the velocity at any instant of time you can calculate with the help of v is equal to u plus ft only in the case where the acceleration is constant. Now if you further integrate this, this is v is nothing but dx by dt is equal to, so u plus ft. Now this one if you integrate it on either sides again, so this is going to be x is equal to, so ut plus half ft square plus some arbitrary constant a. Now at t equal to 0, x is equal to 0. That is the displacement initially when we started. So we start counting from there where we have started. That means x equal to 0 at t equal to 0. Now in that case, so this can be replaced as x is equal to ut plus half ft square. This is the relation between the displacement and time. So at any instant of time, what is the displacement? You can find out with the help of this. At any instant of time, what is the velocity? You can find out with the help of this equation if the acceleration is constant. Got it? So from this actually, so we can prove that. So from this relation t is equal to v minus u by a. Now if you replace it here, then you are going to get the relation, that is v square minus u square is equal to 2fx. So this is the another relation. So where it relates the displacement and the velocities. So if you notice in this equation and this equation, the relations are in between x and t and v and t. Now here the relation is v and x. That means you eliminated t from these two equations. So if t is treated as the parameter, then actually if you eliminate the parameter, you are going to get the relation between the velocity and the displacement with the help of the initial velocity and the acceleration f. Got it? So this is the another relation. Now when we are dealing with the constant acceleration, we are going to deal with this kind of equation. Now here, if you notice, this is nothing but the equation of a straight line. This is at any instant of time, so this is the velocity v and this is the time t. So this is how the relation between v and t. This is the graph of velocity time. Now if you try to draw the graph of x and t, so this is going to be a parabola. So this is the parabola. This is how you are going to get it. So this is t and this is a. Got it? This is how actually it will be treated. Now actually, so first you note down this. We are going to analyze these graphs further. So we have got the relation v is equal to dx by dt. It implies that dx is equal to v times of dt. Now, if you integrate on either side, then x is equal to integral v dt. Now, if you notice, the integral of any curve is nothing but the area under that curve with respect to the x-axis. Now, if you draw the graph of vt, let us say this is v graph. V is equal to u plus ft, and then within a time of starting from t is equal to 0 to t is equal to t1. Now, the area under this curve can be calculated with the help of integral v into dt. Now, here actually mathematically we proved that x is equal to integral v dt. It's nothing but this is the displacement and this is the area. Area under VT graph. Right? So this is area under VT graph. That essentially means that, so any random VT graph, if you try to calculate the area bounded by the curve on the x-axis, it will give the displacement of that particular curve. Got it? So if the velocity variation is like this, then actually the area under this particular curve is nothing but the displacement traveled by that particle. That means, so when, as and when actually the problems are given in this way, that is, suppose if a car started with 0 velocity and then actually with a uniform acceleration it raised to certain velocity, and then actually it started traveling with a constant velocity. From there actually he applied the brakes and then actually finally it came to 0 velocity. So it is stopped finally. Now here the area under this entire curve will give the total displacement traveled between point A to point B. So that is, so this is actually the area under the curve. Gives the displacement. Got it? So this is the velocity and this is the time. And then the displacement versus time graph, actually if you notice, that is displacement versus time graph is this one. So this is x and this is t. Now this x is equal to ut plus half ft square is this graph. Now if you take the derivative of this, then this is dx by dt is equal to u plus, so ft. So this is dx by dt, which essentially means that the slope under the curve. So this is x is equal to ut plus half ft. Now if you take the derivative of this x graph with respect to time, which is nothing but the slope, so this slope will give the velocity. Slope is the instantaneous velocity. Got it? So from the xt graph, you can calculate the slope and then you will be able to find out the velocity there. From vt graph, you can calculate the area under the curve and you will be able to find out the displacement that it got traveled during the time. Got it? So you can note down this. So based on this understanding, these are the only the conceptuals that we have to be aware, and we can note down one problem. A particle moves in a straight line. A particle moves in a straight line with constant acceleration. With constant acceleration. And its distances from the origin from the origin O on the line not necessarily the position at time t equal to 0. Not necessarily the position at time t equal to 0. At times t1, t2, t3, t1, t2 and t3 are x1, x2, x3. x1, x2 and x3 respectively. Show that if t1, t2, t3 form an AP, show that if t1, t2 and t3 form an AP whose common difference is D, and x1, x2, x3 are in GP, and x1, x2, x3 are in GP, then the acceleration is square root of x1 minus square root of x3 whole square by d square. Now this is the problem statement. Now try to solve this on your own. So here actually a particle moves in a straight line with constant acceleration, and its distances from the origin O on the line, not necessarily the position at time t equal to 0, which essentially means that O may not be at t equal to 0. Let us say, so this is the straight line on which the particle is traveling. Now, so on this particular line, the particle is at different locations. This is at a distance of x1. So this x1 is from here to here. Now this is at x2 and this is at x3. So x1, x2, x3 are three different positions from the origin O. So this is the origin O. Now this origin may not be at t equal to 0. So it may be somewhere here actually at t equal to 0. You can take that. So this is at a constant distance of c. So this is what actually he asked us to find out. So here actually after certain distance actually he started traveling at t equal to 0. Then actually if you count from this location, this particle is at a distance of x1 and this particle is at a distance of x2 and this particle is at a distance of x3. Now the time taken to travel from t is equal to 0 to t is equal to some value is x1. So till this point it is x1. So till this point it is t2 and till this point this is t3. So these are the three different times. So t2, t3, so t1, t2, t3 are the three different times where he noticed that the particle is at x1 and x2 and x3 like this. Got it? Now actually based on this understanding, so he asked us to find out the acceleration and he asked us to prove that this is f is equal to square root of x1 minus square root of x3 whole square divided by d square, where t1, t2, t3 are in AP and x1, x2, x3 are in GP. So based on this information, you try to find out the acceleration. So only thing is actually he has given the relations between the different values of t and the different values of x. Now here actually at t is equal to 0, the particle is already at a distance of c. Now, from t equal to 0 to t is equal to t1, so there is a displacement that got traveled in between these two. That means this displacement, so we can count from O to x1 and O to c. That means the difference of the distance between x1 and c is traveled from t is equal to 0 to t is equal to 1, t1. That means, so we have the initial relation, that is S is equal to ut plus half at square. So this is the initial relation. Now with an assumption that the initial displacement is 0. So why is that way is, so actually if you notice, ds by dt is equal to u plus at. Now here if you integrate it, ds is equal to u plus at into dt. Now integrate on either side, s is equal to ut plus half at square plus c. So this plus c is nothing but at t is equal to 0, s is equal to c. That means at t is equal to 0, s is equal to c, where s is the distance from here to here. Now this constant actually we are ignoring, because earlier actually we treated that the particle is started at t is equal to 0 with a displacement of 0. That means here actually we treated as x is equal to 0. But in this particular problem statement, at t is equal to 0, x is equal to c. Hence actually this c needs to be counted. So here s minus c is equal to, so s is actually now actually x1. To travel a distance of x1 minus c, it took a time of t1, because t is equal to 0 to t is equal to t1. That means this equation ut1 plus half a t1 square. So this is x1 minus c value. Similarly, to travel from here to here, it took a time of t2 and it traveled a displacement of x2 minus c. So x2 minus c is equal to ut2 plus half a t2 square. Similarly, the third relation is x3 minus c is equal to ut3 plus half a t3 square. So these are the three relations. Now in these relations, t1, t2, t3 are in AP and x1, x2, x3 are in GP. Now actually these are being AP. If I wanted to make the relation between all these three variables together to come as a simple 0, then actually I can count that this is equation number 1 and this is 2 and this is 3. So what I will do is count 1 plus 3 minus 2 times of 2. So this way I can make out elimination of this t, and at the same time this t also will be going out, because t1, t2, t3 are in AP. So if t1, t2, t3 are in AP, then t1 plus t3 by 2 equal to t2. Now from here actually t1 plus t3 is equal to 2 times of t2. Or actually if I bring this to t1 plus t3 minus 2t2 equal to 0. Now by making this kind of relation, I can make this part to 0. So that is the only hope. And this side also c plus c minus 2c. Again actually this part also I can make out to 0. Now actually I can think of elimination of this x1, or actually I will try to find out the relation between x1, x2, x3 and t1, t2, t3 depending upon the relations of AP and GP. So with this understanding, if I do this on the left side, that is x1 minus c plus x3 minus c minus 2x2 plus 2c. So this is on the left side. So this c and this 2c will cancel out. On the right side, what I can get it is, so first you note down this, I am going to erase it and then write it. So from this relation, x1 plus x3 minus 2 times of x2, on the right hand side, what we are going to get it is, that is u times of t1 plus t3 minus 2t2 plus half a t1 square plus t3 square minus 2 times of t2 square. So this will become 0 because actually this is coming out to be 0. Then x1 plus x3 minus 2x2 is equal to half a into t1 square plus t3 square minus 2 times of, again, t2 equal to t1 plus t3 by 2. So you can substitute this value here, and then this side, so x1, x3, x2 and x3 are in GP. Hence, x1, x3 is equal to x2 square. So this is a relation of GP. Now you can replace here. So x2 I can treat as square root of x1, x3. Now if I replace it here, x1 plus x3 minus 2 times of square root of x1 square root of x3. And this I will call as root x3 whole square and root x1 whole square. Now this is, if you notice, root of x1 minus root of x3 whole square. This is on the left hand side because it's a square plus b square minus 2ab format. So on the right hand side, so what we are going to get it is, after simplification, so half a into, so this 2 will cancel, and out of 4, then actually 1 by 2 will be left over, and if you take the LCM, then this is by 2, again it comes a by 4 2t1 square plus 2t3 square minus 2 times of t1 square plus t3 square plus 2t1 t2 t3. So this after simplification, a by 4, so so this 2 won't be there, yeah. So now actually 2t1 minus t1 square, this is t1 square plus t3 square minus 2 times of t1 t3. Now this one, a by 4 t1 plus t3 whole square, sorry, minus t3 whole square. You note down till this point, we are going to erase and then write it. I'll write this here. A by 4 times of t1 minus t3 whole square. Got it? Done? So from this relation, left hand side what we have got is, so left hand side, square root of x1 minus square root of x3 whole square is equal to right hand side a by 4 times of, so t1 minus t3 I can write as t3 minus t1 because actually it won't make any difference because of the square on the top. So this relation, so t1, t2, t3 are in AP. Hence T2 equal to A plus T1, D plus T1 and T3 equal to D plus T2. It implies D plus T1. Then T3 minus T1 is equal to 2 times of D. This is the common difference. So this common difference actually if you replace it here, then what we are going to get it here, it is, that is square root of x1 minus square root of x3 whole square is equal to a by 4 times of 2d whole square. So this is a is equal to square root of x1 minus square root of x3 by d whole square. So this is the acceleration. Got it? So this is actually, if you notice, conceptually in rectilinear motion, no complexity. That is pretty straightforward and simple. So only thing is actually you have to be aware of how to interpret the words into the mathematical format. That is the only thing you have to be aware of it. So here actually the problem will be described in terms of the words. That you need to put it into equation formats. So only thing, if you notice in the entire context, right, we are trying to simplify with the known relations, nothing more than that. But the concepts are only few concepts. That's what actually I have explained within the first 10 minutes of the class. So that 10 minutes itself is the rectilinear motion complete class. But only thing is you have to be knowing all these simplification parts and interpretation of each and every word into the mathematical format. Got it? Two cars start off to race with velocities u and u dash. To race with velocities u and u dash. And travel in a straight line with uniform accelerations. And travel in a straight line with uniform accelerations. F and F dash respectively. F and F dash respectively. If the race ends in a dead heat, prove that the length of the course is length of the course is 2 times of u minus u dash into u f dash minus u dash f divided by f minus f dash whole square. Can you try to prove this? Here actually, see this, two cars start off a race with velocities u and u dash. The initial velocities of both the cars are different, but they started with the same position. So both started with different velocities and both are having different accelerations. But actually the race ended on tie. So dead heat, I mean here it is the tie. That means nobody won the race. So both are traveling with the equal time and equal velocities. But initial velocities are different and initial accelerations are different, both of these. But the time is same and the distance traveled is same. Now in that case, so what is the displacement that it got traveled? So that is the question. Got it? So to travel the same distance with same time but with different initial velocities and different accelerations, how much is the displacement? That is the question. Got it? So can you try to solve this? Anybody got the answer? So this is pretty straightforward question. Yeah, okay. So this is actually pretty straightforward question. So with constant acceleration, the displacement traveled is ut plus of ft square. So this is the constant acceleration displacement. Now, this is actually the first person, and the second person also he traveled the same displacement but with a different initial velocity, and he took the same time and with a different acceleration. So this is equation number 2. Now actually it is up to us to solve these two equations, nothing more than that. So here actually, so this f by 2 times of t square plus ut minus s equal to 0, this is equation number 1, and f dash by 2 times of t square plus u dash t minus s equal to 0. So this equation is 2. Now actually we have to solve these two simultaneous equations to get the value of the displacement s. That's all. Now actually, so we know these equations, right? So ax plus by plus c equal to 0, a1 b1 c1, a2x plus b2y plus c2 equal to 0. Then actually, so this actually you can write x by, so b1 c2 minus c1 b2 is equal to y by c1 a2 minus c2 a1 is equal to 1 by a1 b2 minus a2 b1. So this relation actually I think everybody is aware of it. So this is actually the method to solve the simultaneous equations. Now actually here actually in place of x and y, so in place of x it is t square, and in place of y it is t, and in place of c1 it is s minus s in fact. So that's all. So replace in this equation, you will get t square and t, and then actually in the parametric form you can eliminate the t value and try to get the value of s, or actually whatever may be the method you can adapt to solve these two equations and find out the s value. So that is up to you how to solve it. Now actually that s will end up with this one. Got it? Now actually, so now you can solve it I think. So try to put it in this equation. This is t square, this is t, and this is simple 1 and divided by, so this value we have to put it. T square by minus us plus u dash s is equal to t by minus s into f dash by 2 plus s into f by 2 is equal to 1 by f by 2 times of u dash minus f dash by 2 times of u. So this is the relation. Now from these two relations actually you can get the value of t in terms of s. From these two relations actually you can get the value of t in terms of s. Try to equate these two and then you will get only the unknown variable s. That's all. So from these two, t you can write as u dash minus u times of s divided by so s into f by 2 minus f dash by 2, and from here actually you can get t is equal to s times of s by 2 times of f minus f dash divided by f u dash minus f dash u. So this is the value of t. Now actually from this actually you have got the value of t, and you have got the value of t again in terms of s. Now this t actually you can replace this value, and then you can keep s on one side, you are going to get this value. Got it? Vishal? The greatest possible acceleration of a train is, I think for this you need calculator. Maybe we'll solve one more. The speed of a train . the speed of your train increases at constant rate, alpha from 0 to v, alpha from 0 to v, then remains constant for an interval, and finally decreases to 0 at a constant rate beta, and finally decreases to 0 at a constant rate beta. At a constant rate beta. If L be the total distance, described then prove that the total time occupied is is L by V plus V by 2 times of 1 by alpha plus 1 by beta. Also find the least value of the time. When alpha equal to beta. So this is what actually is the question. Now here if you notice, so this is the graph actually what I have drawn previously. That is, a train started traveling with 0 velocity. This is usually the case. Suppose actually a train started from Hyderabad. Now actually the time actually when it starts with 0 velocity. And then actually it keeps on raises to certain velocity. That means when it raises to certain velocity, it maintains a constant acceleration. And that rate of velocity change is nothing but the acceleration. So that means this line is having a constant slope. This is the velocity time graph. So in the velocity time graph, so dv by dt is maintained constant. That means it is maintaining a constant acceleration. And that acceleration is nothing but alpha. And then once it reaches certain level of velocity, then actually it tries to maintain that velocity, but it won't continue to infinite, right? So it starts from 0 and raises maybe 100 kilometers per hour or actually 150 kilometers per hour, and then actually it tries to maintain 150 kilometers per hour till the point actually it reaches Bangalore. But actually when the Bangalore reaches maybe within 10 kilometers or 15 kilometers, then actually they started putting the deceleration on it. That means it maintains that velocity for certain duration of time, and then actually so they start applying brakes, and then actually finally it will comes to 0 velocity. This is velocity time graph. So it raises with certain velocity rate and it falls with certain velocity rate, and the slope of this is alpha. That means the acceleration is alpha and the deceleration is beta. So deceleration, if you notice, this is positive angle theta, and this angle, so this angle is actually theta, so phi, and this phi being greater than 90 degrees Hence actually the slope is negative. Hence we call as the deceleration there. Now actually the area of this curve is nothing but the total distance traveled from Hyderabad to Bangalore. Right? So here actually there are three different parts. So in this part actually there is a constant acceleration. And here actually there is a constant deceleration afterwards. But in between there is a constant velocity. In case there is no acceleration, so the displacement that it got traveled is, so we have actually S is equal to ut plus half at square. Now in this case, if a equal to 0, S is equal to ut. So S is equal to ut, velocity multiplied by time will give the displacement directly. You don't need to be worrying about half at square because the acceleration is 0 in case of constant velocity. But the rule of area under this curve still it is acceptable because so this height is v or u. So this height is v and the time taken in between these two, let us say this is t, the area under this curve is vt. So area under the curve still applies to the displacement even with the constant velocity or with the constant acceleration. That is independent. Even with the variable acceleration also, integral v dt will give the displacement traveled. Now in this particular scenario, if this rate is alpha and if this rate is beta, then actually he asks us to find out the total time taken from here to here. So in this case actually it took a time of t1 to travel from this location to this distance. And then actually it took a time of t2. So this is actually time t2 and from here to here it took a time of t3. So he asked us to find out t is equal to t1 plus t2 plus t3 in terms of total distance. The area under the entire curve is L. So that is the total distance. So and the velocity it reaches a maximum value that is v and it maintains there. From there it comes to 0. So with this understanding, try to prove this relation. Without even knowing any mechanics, with the help of this graph itself, you will be able to prove this relation. So here actually we can get the relation if this is t1 and obviously the slope is alpha, then actually v is equal to alpha t1 is this relation. So this is actually a straight line equation. Now these coordinates are t1 and v and these coordinates are 0, 0. Now this straight line equation is nothing but v is equal to alpha t. Now actually at t is equal to t1, v is equal to alpha t1. So this is one relation. And another relation is from here to here. If you notice this t3, if you count it from this location, then v is again equal to beta times of t3. So if you look at from this side, actually you will be able to make out easily, right? So these are the two relations and actually it maintained a constant velocity in this particular duration of t2. Now let us say the displacement traveled for t1 is x and this is for y and this is for z. Now actually total displacement so that is what is L. He has given x plus y plus z is the L value. Now this L value is equal to x plus y plus z is equal to, so this value you can calculate, this x is equal to the area under this curve is nothing but half base into height plus y is the area under the other curve, that is v times of t2, and then the third one is half base into height. So this is the total displacement traveled. Now from here actually, so this is if you take out v, then t1 by 2 plus t3 by 2 plus t2. So for this actually what I will do is I will add t1 by 2 and subtract t1 by 2 and again t3 by 2 minus subtract t3 by 2 for this one. Now actually this L is equal to, what we can get it is if you add these two, this one and this one, if you add it, t1 plus t2 plus t3 is the total time minus half of so minus half of v times of T1 plus T3. So this is T1 plus T2 plus T3. Got it? So this is the total length value. Now the total time taken is nothing but the time taken from here to here in the entire length. Now actually, let us say this is traveled a distance of s. I think so. What is the information here given? So he has not given the displacement information. So actually you can keep it as it is in that case. So total time taken. So this you can calculate, this T is equal to T1 plus T2 plus T3 is equal to L by V times of plus 1 by 2 times of T1 plus T3. So this is what is the total time taken. So this total time taken you can further simplify as L by V plus half this T1 you can get it from this relation T1 is equal to V by alpha and T3 is equal to V by beta. So if you replace it here, this is V by alpha plus V by beta, or simply you can write this as T is equal to L by V times of plus V by 2 times of 1 by alpha plus 1 by beta. This is what actually he asked us to prove. Got it? Understood? Now the second part of the question is, this T value is minimum. Find the relation when alpha equal to beta. That means if alpha equal to beta, then actually for what value of velocity the T can be minimum. Now if you notice the area under this curve, right? So actually this can be increased further or this can be decreased down. So this V value can increase up and you can decrease down, and then actually correspondingly this curve actually will shrink so that it wanted to maintain the same displacement. That means without changing the area under this curve, if I push this down and then actually lift this high, then actually still the area will be the same, but the time taken is different, but the velocity will be different. So velocity, time and are actually both are different, and then you can get actually infinite number of ways to travel the same displacement with different velocities and with different times. Now the problem statement is, for what velocity actually I will take the minimum time to travel the same displacement. From this relation we can make out, there the assumption what he asks us to take is, this slope is equal to this slope, alpha equal to beta. Deceleration slope is equal to acceleration slope. So with that understanding, so I hope you noted down this. So to have the same velocity, right, I can draw this way. So I can have the same area even this case also. But here actually this V is different and this T total time is different. Here T is different and here V is different. But V is a function of time. Got it? So this V value is a function of time. So the area is nothing but, so is the displacement that it got traveled. So if this S is equal to this S, then actually what could be the least value of time I can take it, so that I can raise this velocity to certain value and maintain there, and then actually try to apply brakes so that I can decelerate with the same deceleration what I have when I am doing the acceleration. So in that scenario, T is equal to L by V plus V by 2 times of 1 by alpha plus 1 by alpha, because actually alpha equal to beta he asked us to take it. Now if this is the case, this can be treated as L by V plus V by alpha. This is the value of T. Now from this relation, this T and V are the variables. From that graph actually we can make out. So dt by dv equal to, so minus L by V square plus 1 by alpha equal to 0, or L by V square equal to 1 by alpha, or V square is equal to L alpha, or V is equal to square root of L alpha. This is the velocity. Now if this is the velocity, then actually if I put it here, so I can find out d square t by dv square, then minus L into minus 2 divided by V cube, and this value 2L by V cube, V being the velocity positive, then 2L by V cube is a positive value. Hence, T can be minimum. So, minimum value you can find out from the relation of V is equal to square root of L alpha. So, if you replace it here, so T is equal to, so L divided by square root of L alpha plus square root of L alpha divided by alpha. So, this is square root of L by alpha plus square root of again L by alpha. So this is T is equal to 2 times of square root of L by alpha. So this is the least possible time that we can take out to reach the same distance by making changes to the velocity. Got it? So these are the kind of different types of analysis what we are doing with the same fundamentals. Got it? So these are the actually different kinds of problems that we can think of so that you can solve all these kind of models. Last part, see this. Here actually the second part what he said was, so this is actually he has applied certain acceleration and traveled with the constant velocity and applied deceleration and to come to the zero velocity. In between actually he traveled the velocity which is equal to the area of this curve. Now here actually taking alpha equal to beta, the slopes in either case are the same. That means with what velocity he raised, he braked actually with the same velocity. Now actually with this understanding, so it took certain time t which is the length of this particular curve, and it took certain velocity which is the height of this curve. Now actually I have got the flexibility to have the same area, but I can increase the velocity and reduce the time this way. It's actually what is the least possible time I can take it. This time actually is minimum for what value of V? That's what is the question. Now actually I can reduce this t and then I can increase V so that I can maintain still the same velocity, keeping alpha equal to beta. So with that understanding, if you want to find out that relation, so we have got the relation T is equal to L by V times of V by 2 times of 1 by alpha plus 1 by alpha. So this 1 by alpha plus 1 by alpha because alpha equal to beta. Now from this actually T is equal to L by V plus V by alpha. Now here actually V is one variable and T is one variable. From this graph we can make out. If these two are the variables, then with respect to V, if you take the derivative, you will be able to find out the minimum value of T, taking V as the variable here. Now for that actually you just take the derivative, equate to 0, find the value of T, and then take the second derivative and then prove that this is plus, so that you can get the minimum value for T. So this is just normal calculus to find out the minimum value from this relation by varying V. That's all. Got it, Zakir? Okay. So with this actually I would like to stop the class today. So I hope you got a fair clarity on this. In the next class actually, so I am going to take up simple harmonic motion.